Welcome back. We're in Module 2, specifically Unit 2, Chapter 2 of FMT100. And we're looking at tools this time, which is kind of nice. I mean, we got safety aspect taken care of. Now we need to move on to tools because we use tools to get our jobs done. So, what we're going to look at is by the end, we should know the importance of inspecting hand tools. We're going to look at the proper way of using various types of hand tools. We're going to look at some of the more common types of power tools, and we're going to discuss the many safety issues when working with electricity and power tools in general. A lot of that, the electricity side, was already discussed a little bit, but we're going to continue to expand on that. And we're going to list the proper and improper use of each power tool, and as well as some of the hand tools, and discuss the importance of inspecting all power tools before and after their use. Well, before we get into power tools, though, let's get into hand tools. So one of the most common pieces of tools that we're going to use is the group known as wrenches. And oh, good gravy, there is a ton of them. Now, in case you're wondering, you notice not a lot of photos or pictures right now. If you want some, there's some in the book, but hang on. When we get to the lab, I will be giving examples of all, or as many as I can, of the different tools we've described. All right, so hang on to lab, and I'll make it worth your while. All right, got a decent array going up, but let's get rid of this lecture first. So, wrenches. The most common or the most classic, iconic, is the open end, and that's going to be a wrench that literally has open ends, and you slide the wrench over the bolt or the nut, and that's the way you tighten it. Now, not the world's greatest. They can open up, they can strip out, and to reduce that, we created the box end. And in this case, the wrench completely encircles the nut or bolt and increases the points of contact, whereas the open end wrench typically only has really 2 points of contact on the nut or bolt. It kind of sucks because that is like the fastest way to strip out a nut or a bolt. The box end, because it encloses more of the bolt or nut, we now have more points of contact. And so we reduce the risk. I didn't say it was impossible. We reduce the risk of stripping out that nut or bolt. Now, that's fine and dandy. There are combination wrenches, which I think is the more popular one. And with the combination, you'll have a box on one end and an open end on the other. And for these, they're kind of handy. And now they even come in ratcheting style. So that is also really nice. So you get the combination of both a box end and a ratchet or a socket, if you will. There's also the adjustable wrench, and everybody goes, well, what the hell is that? Think a crescent wrench. A crescent wrench just happens to be a brand name, Crescent Tools, and Crescent was the one that came out with the first adjustable wrench. It's an open-end wrench, and it's really nice. It's handy. You got one tool for many different nuts and bolt sizes. The catch is it needs to be properly adjusted in order to reduce stripping out our nut or bolt. We also have a flare nut wrench, specifically designed to make the most contact area on a flare nut while we are tightening and or loosening up a flare nut. Really, really popular with refrigeration technicians as well as anybody else that's using flare nuts. It's a handy piece to have. We also have socket, the ubiquitous, ever glorious mechanics socket. Yes, that same type, and various configurations, not only in sizes but also depths, as well as different points of contact. And yes, now they even have torque sockets and everything else. Speaking of torque, we also have torque wrenches. Now, torque wrenches, really, really, really important because they help you properly set or tension a bolt. So depending on the task at hand, if you come across a specification that says the bolt needs to be tensioned to, and it's usually done in foot-pounds for our method, and you need to bring that bolt to that tension properly. All right. Uh, Essentially, you're going to work it up. What I tend to do is I tend to do it if it's a small increment, like 20, let's say 25 foot-pounds. I'll go, okay, so I'll take 25 and I'll divide it into 3. And so my first set is uh, 8. So I'll torque my first set of torques goes to 8 foot-pounds, and then for the next set it'll be 16. And then last but not least, I will finish off with 25. Yes, I know. 25 divided by 3 is a little bit more than 8. Yeah, you work with it, all right? And if it is very specific, your technical manual will tell you the steps that you need. The first step, you torque 2. Second step, you torque 2. Third, fourth. You just literally follow along what the manual says, and away you go. So, torque wrenches. There's different types. I've got specifically one type, and that is the dial. So I'll show you that one. Like I said, once again in lab. Oh, God. Screwdrivers. The most common types are flat tip and Phillips. Flat tip is our regular everyday screwdriver, not the drink, the tool. And then we've got the Phillips. It's cross tip, whatever else you want to call it. But then we get all sorts of different screwdrivers out there. Now there's specialty screwdrivers for just doing the terminal screws on receptacles and light switches in residential and commercial buildings, or I should say commercial installations. There are Torx, Torx. That's how you Torx screwdrivers, which are a funky star shape. The list just kind of goes on. It just gets insane. Screwdrivers, especially the flat tip, as it says, they often get misused. Yes, I have seen them used as a pry bar. I would never do that. As a chisel, oh God, they are. You'll do it once and you'll go, yeah, I'll never do this again, because it does not operate the same way as a chisel. So don't even try it. Get the proper chisel, or you'll have to find some other way. Screwdrivers make hideous chisels, just so you know. I've also seen screwdrivers used to test if there's a voltage on places that they should not be using a screwdriver to test if there's a voltage. Seen screwdrivers used to drain the charge on capacitors. Once again, please don't do that. That is bad juju. You end up damaging that screwdriver. So it is not a good practice. Screwdrivers are used to drive screws, either pushing them in or pulling them out. That's all screwdrivers are supposed to be doing. So we've got other types of screwdrivers. Reed and prints. Now reed and prints look pretty much the same as a Phillips. They are slightly different enough where you won't get good results if you try and use a Reed and Prince driver with a Phillips screw. The Reed and Prince tends to have a deeper angle to it, and it just gets to be problematic. Stubby screwdrivers. Stubbies are nice. Usually they're pocket size, which makes them really handy. Your combination of either Phillips or flathead, and some are combination, which makes it nice. And you can get into tight places where a regular full-length screwdriver would not fit. There are tighter situations, which we have another screwdriver we can do, and we'll get to that in just a moment. But so stubbies are nice, where a regular full-length screwdriver is not going to go in. A holding screwdriver holds your screws for you. Isn't that nice? It is actually very nice, depending on what's going on, especially if you're trying to put a screw in that you have some distance between your hole where it's going and where you can get your hand. Sometimes you can't get your hand and hold that screw, and it'd be nice every once in a while where the screw would stay attached to your screwdriver. And there's several different types of holding screwdrivers. I'll show you what I've been using, and we'll go from there. So if you've got a spot that's really, really tight, and you cannot even get a stubby screwdriver in, an offset screwdriver is probably going to be your ticket. And it's usually a screwdriver. It looks like it's been, well, it looks like it's kind of been through a wringer. It's a nice long shank, and then each end is offset 90 degrees. And that little offset allows you to get in there and get the screw moving whichever direction you need it to move in nice tight locations. They can be tricky to use, but they are handy when you get to use them because usually nothing else will get in there. And yes, there are ratcheting screwdrivers, so that way you always keep pressure on the screw that you are working with, either removing it or installing it. And instead of taking your hand off the screwdriver and resetting your hand, you just twist your hand and away you go. So different tools for different applications. And I like I said, I will share with you what I use, and I'd like to think it's a diverse assortment and a great example of what's out there. Pliers are another one. There's various types. To be quite honest, linemen. My background is electrical. I was an inside wireman. That was my trade and training. So I did commercial and industrial electrical installation, troubleshooting, and all that stuff. And lineman pliers. For years, I still kind of do carry a pair of linemen's with me, a multi-tool screwdriver, an adjustable crescent wrench, and a flashlight. So yeah, that's usually what's hanging with me. There's also long nose, needle nose pliers. Those are nice to either hold said screw when you're trying to get it in, and or to reach and loosen and move things around. You can also use these long nose or needle nose pliers to help bend wire appropriately. So a lot of different uses with those. Not so many uses with diagonal cutters. Diagonal cutters are nothing more than wire cutters set at an angle. I know they went out on a limb to name this one, right? And you're going to be cutting copper wire. You can cut aluminum, yes, but do not cut steel wire or cable with these. They will not work, and they will not like you. They will tell you very nasty things about you, especially when you try to cut steel cable or wire with them, and you leave this big old hole in the cutting surface of your diagonal cutting pliers. You think it's not possible, you'll do it once, you'll cuss, you'll remember this conversation and go, damn, he was right. Nuts. Now we've got into the gripping stuff. We've got slip joints. They're not the greatest. They tend to literally slip, but you can adjust the size of them through a slip joint. Not my preferred, but if that's all I got to use, I'll use them. My preference, if I have to do an adjustable gripping one, tongue and groove is the way to go. I've got several examples of those. There's also locking. You're all, what? Locking. Vice grips. That's what vice grips are. That's all vice grips really are, is locking pliers. Vice grips happens to be the brand name for vice grip locking pliers. So everybody looks at locking pliers and just calls them vice grips, regardless who makes them. So now you know. Hey. So hammers. Hammer is a striking tool. I know they went on a limb to tell us that one, bless their hearts. There's various types. There's claw, and there's different types of claw hammers as well. I will show you examples of those. Ball peen, also known as a machinist hammer. There's the tack hammer. Yep, they've got little hammers for little nails and little brads and little tacks. There's dead blow. These are a hoot. These are typically a rubber rubber-coated mallet type hammer, and inside the hammer head is lead shot. So what happens is as you get the hammer, you swing down and you make contact with your object, surface, or whatever, all the lead shot goes and hits the face that's making contact with whatever you're striking, and then the shot just kind of disperses within the hammerhead. So what happens is you don't have a bounce back with the hammer. The hammerhead comes down, hits, and basically stays on target, which is rather nice. Depending on what's going on, dead blows are very, very sweet. If you don't want to mark anything, there's also rubber mallets where you need to impact something to give it a little oomph, but you don't want to leave any evidence behind. And there's also, instead of rubber, there's also specific non-marring heads on particular hammers as well. So once again, for a specific application, I guarantee you there's going to be a specific hammer out there. And you may find yourself developing a selection of hammers, much like you can develop a selection of chisels. And the chisel is a struck tool. Typically, if you're striking a chisel, you're going to be using either a claw hammer or a machinist hammer. And while there's various types, they break down into two basic ones, either the wood chisel, obviously used for wood, and then the hardened or the cold chisel, and that's used on metal. So the wood chisels tend to be very, very, very sharp because that is the best way to cut through the wood and leaves a nice clean mark. Once again, if we are trying to chisel something, we use a chisel, an appropriate one. Wood, if we're working with wood, we use a wood chisel. And this is usually where the screwdriver, the flat-bladed screwdriver, comes in. That's a no-no. Use a wood chisel. Hardened chisel or the cold chisel we use on metal. We'll use it to gouge out and clean out tracks on motor shafts so we can put in a drift or a bar or a chuck, however else you want to describe it. And what we're trying to do with that is we're trying to get this channel inside the motor shaft nice and clean, and we have to clean it up every now and then with a hardened chisel. Don't use a wood chisel, you will damage it. And anytime you use a wood chisel or a hardened chisel, please wear eye protection and hand protection. As I promise you, the first time you don't, well, maybe not the first time, but at some point, if you don't wear that, you are going to have a problem. So don't be that problem. Oh my gosh. And punches. This is another strike tool. Various types of punches. The most common that we tend to bump into are going to be the center punch. And center punches are used to mark where you want to drill, and it also keeps the drill from drifting out from where you want to drill the hole properly. So you center punch the point, the place where you want the drill bit to stay, right in the center, and away you go. Prick punch, kind of this, again, I can't say it that way. Typically we use that to mark and or to try and push items through. The best one for that, though, if we're trying to push something through, is going to be the drift punch. And this one, we are usually trying to drift pins in and out of shafts or bolts or nuts. So drift punch. And or we'll also use them to drift pins out of anything that we're trying to hold two pieces of material together. So the most common punches that we are going to bump into and use are going to be the center punch and the drift punch. Sounds like a rock band. Drift punch. Files. Well, used to cut away material, blah, blah, blah. Look, with files, we're trying to remove material, but we're not trying to cut through the material. All right, we're trying to smooth it out or we're trying to shape it. Various types. We got the rasp, bastard cut, second cut, smooth cut, all the way around. Rasp are very, very rough cut files. Typically, you will use a rasp on soft material like wood. All right. Then there's bastard cut. Bastard cut, think of it as a rough cut file, but typically now we're using a bastard cut when we want to remove a lot of material. Specifically in this case, we're looking at metals, soft metals, hard metals, and whatnot. We'll use a bastard cut. And then to smooth out our removal process and our shaping, we start using a second cut, and then we finish off with a smooth cut, because those two help get the surface finer and finer, and it's almost when you're done with a smooth cut, it's almost like you've polished it. You still have more work to do, but that's essentially what you're going for. Yes, it takes time. You let the file do the work. You don't push down on the material. You push across and through the material. All right. So how do we have our cuts? Well, they can be a single cut, so it's just one set of grooves, or a double cut. And the double cut, you'll literally see it, especially towards the bottom of the file, close to the tang and the handle, and you'll see two sets of diagonal lines. And where the two sets of diagonal lines meet, and it starts looking like diamonds, well, that would be a double cut blade or a double cut file. Really, really nice. Single cut are nice because they're easy to clean out. Double cut are nice because you get a lot of cutting done, and it's usually a finer cut. But the catch is those tend to load up really quick and are really a pain to clean out. So parts of a file, we've got the point, edge, face, cutting teeth, the tang and handle. I will do my best to remember to point these out when I'm showing you the different files that I have and that I continuously use on the farm. This is the profile, the cut cross-section of what a file looks like. So we got a mill file, relatively thin profile, and then we've got the flat or pillar file, the chunky monkey of the mill file. We've got the half round, because it's half round. Triangle file, yeah, round file, and square file. Yeah, look, all we're trying to do now is with the various shapes is we're either trying to get the file in a place where we can remove material, all right, or we're using the shape of the file to help form the shape that we're trying to get done. Okay, so that's what we're going for here. That's why we've got the different shapes. We're literally matching the shape to what we're trying to get done, how we're trying to form and shape whatever material that we're using. So hacksaws, disposable blades used to cut metal primarily, although they can cut other things. And blade lengths range from 8 to 16 inches. I'm more familiar with the 16-inch, although one time I did have the smaller 8-inch. It's kind of nice to have. Very portable, lightweight. You can get really good at using them. The catch is where most people tend to screw up is they push too hard on the blade and they go too fast. Both of those things wear out the blade really, really, really fast, and also makes cutting an absolute nightmare. As I kind of joke, it's supposed to be kind of relaxing and therapeutic to be using a hacksaw, because you just kind of take a deep breath, you relax, let the saw do the work, and you just take your time. Do a nice rhythm, use the entire length of the blade. You got a full blade, use it, and away you go. And apparently that was funny to the ducks. They thought that was hilarious. Bless their heart. So let's look at some of the teeth sets, and you can kind of get an idea what the blade is supposed to be used for by looking at it. And this alternate set, if you look at it, is really, really aggressive, and that is for softer material. And then as our teeth get closer together, they become less aggressive. We're looking at harder and harder material. And we can see that progress from the left to the right. And our final set is the wave set, and you see that the teeth are pretty much in line with each other. They're offset just a wee bit, and that is for our harder material. So the good news is we are done with this section of the video lecture, which is awesome. Get ready. We're going to hit measuring devices next. So go ahead and click on, and I will catch you at the end of that one as well. All right.